This is question 2, part A, and here we're going to use the Newton's method to approximate the root of a function, or as the question writes here, the zeros of the function. So we have to continue finding out the root until we find two successive approximations that differ by less than 0.01. So we'll continue finding out approximations for the root until two of the successive approximations differ by less than 0.01. Now here's our function given to us and an interval. First, I would like to tell you that for Newton's method, we wouldn't need an interval because we need only one starting value. So you could choose for your x0 to be our initial value x0 to be any value from this two. Like you could choose -2 or 1 because two of them are given to you. So anywhere you start, you will ultimately reach the root. So I would take for this question here x0 as -2, let's say. And what's the formula for Newton's method? So Newton's method formula is xn plus 1 is equal to xn minus f of xn divided by f dash xn. That's the formula for the Newton's method. So here we see that we need to find out the f derivative, the first derivative of the function. So we have the function already, f of x is equal to x cubed plus 4. So what would be f dash of x? So we'll have that one would be 3 times x to the power 3 minus 1, that's 2. And then the plus 4 we don't need to write because that, I hope you know the differentiation, because this would mean that x is here but to the power 0, and 0 times 4 will make it 0. And then 0 times anything will be 0. So yeah, there is nothing to be written for that. So we have got our function, we have got our first derivative of the function, and we have chosen our initial value for x0. So we can go ahead and start our approximations now. So here I'll just write here n to know we're on which number approximation, and then okay, write a bit down here, and then here we have xn to know which number of x it is, the value of that, and here we'll have f of xn. So that's the function. So rewriting the function again, the function for us is x cubed plus 4. Okay, sorry about that. X cubed plus 4. And then we'll have the derivative of the function. So we have f dash of xn, and our f derivative of the function is 3x squared. And then finally we will use the Newton's formula, that's xn plus 1 is equal to xn minus f of xn divided by f derivative of xn. Okay, so now let's start here. So for the first one, we have here, we have to find out x1. So x, basically maybe you can say we'll start from 0 because I wrote here 0, or we could just say here as this is x1 maybe. So then let's write this as x1. So x1 here will be, in that case, now -2. If I wrote x0 there, then I would have to number n from 0. So because I numbered n from 1, so I numbered the initial value as x1. Now we have f of x1, that is putting in the function -2, we have -2 cubed plus 4. That would give us -4. Maybe I'll write down the work. So we have here -2 cubed plus 4. That's -8 plus 4, which is -4. And then we have here 3 times -2 squared. That's 4 times 3, which is 12. And then here we'll get now x2, which is equal to xn, that's 1. Sorry, not 1, -2. Minus, we have f of xn, that's -4 divided by f dash xn, that's 12. So that would be equal to -1 point up to 4 decimal places would be 6667. Okay. Now, for n2 now, we have x2 value would be equal to, as we got, that's -1.6667. And then we have f of xn. So if we put the value of x here, or x2 inside the function, we'll get now -0.6296. And the first derivative with x2 value here is -1.6667. We'll get here 8.3333. And then here, if we put it inside our formula for the Newton's method, we'll get the value here as -1.5911. So then we have, for the third one now, we have -1.5911. And then we have here -0.0281. And for the first derivative using the x2 or x3 value, so I'll just write here x3 so it's more clear to see. So x3 value, now here we have for the derivative 7.5949. And then for x4 now, we'll get the value as -1.5874. So again, just going behind, we need 2 successive results of the Newton's method to be less than 0.01. So here, I don't know if you subtract this to what you get, but let's go one more step ahead. We go to step 4. So x4, we just got the value is -1.5874. And f of xn will be here 0. And then here we have f dash xn to be equal to 7.5596. And here we have x5 is equal to -1.5874. So as you can see over here, the very first thing here is we just got a 0. So that means this is where the y-axis is equal to 0 and the value of x is equal to minus 1.5874. So we reach the root. But this is not how you're supposed to check usually. What you're given here is that the approximations differ by less than 0.01. So if you subtract these two here, they don't have any difference, they're actually the same. So if you subtract, you get 0, so which is less than 0.001. So yeah, we can stop here and we can say that the root, or as written here, the 0 of the function, therefore the 0 of the function is at x is equal to minus 1.5874. So that would be the answer to this question.